All right, this is lesson 2.1.2. Be sure you have your name on it, today's date, and the period number as well. 2.1.2 says, how can I measure steepness? Of course, steepness, you know it's going to be like a hill. A hill can be going up, a hill could be going down, a hill could even be going flat at the top. All this has to do with one word. What is that word? Steepness is, yes, it is slope. So all lines have a different steepness unless they're the same line positioned somewhere else. So this lesson talks about comparing change in y over change in x. Yes, the word delta, you can write this down if you didn't write it yet. Delta is a Greek letter that represents change. So change in y and change in x. In the previous lesson, you determined the growth, slope, and the starting value, b, of geometric tile patterns, and made connections between the pattern table and the equation. Remember, these equations are something you should memorize as quickly as you possibly can. It is y equals, what are the equations of all lines? You got it, mx plus b. So m is the slope and b is the y-intercept, also known as figure 0. Figure 0, or the 0th term. Okay, during this lesson, make sure you're asking this question: what makes a line steeper? What makes lines less steep? How is growth related to steepness? And where is the starting value on a line? If you know the answers, this is wonderful. We can answer this one really quick. Where's the starting value on a line? Yeah, if we have the x and y axis, x is the horizontal axis, y is the vertical axis, and the starting value just happens to be somewhere on this line. For example, this one would be 0, 2, and that's your starting value. Okay? Let's flip our page. Let's make sure we have these notes complete. Okay, problem 2-11. 2-11 asks us to represent this table, this tile pattern, from a table and input it onto a graph. So we're going to decide that these numbers are the x value, which is the figure number, and the y value, which is the number of tiles. So you can see this is labeled pretty tiny, but we have an x right there. Make that bigger, please. We have a y right there, make that bigger as well. Let's check if we have the same answers for this graph. So it says 0, 2. That's going to be, well, let me put this in blue. 0, 2 is my starting value. I'll go ahead and write that down as 0, 2. 1, 7. X is 1. Y is 7. Wow, that's a lot of growth. X is 2. Y is 12. 3 gives us 17. And 4 gives us 22. 22 goes off the graph, but we can go ahead and label it right there. The next thing it says is, should we connect these points? Well, the answer is, you could have thought about this. Should I connect the dots? Do I want to connect the dots? I love to connect the dots. Connecting the dots is fun. But is there such thing as a figure where x is figure number? Is there such thing as a figure number 5? Yeah, somewhere. Is there such thing as a figure 3? Yep, it's right there. Right there. Is there such thing as a figure 2.5? That's where we're having issues. So should we connect the dots? The real answer is no. Unless you're modeling the growth, with a straight line. Flip your page. Let's go to the next one. So it says on that problem we should draw a continuous line through the tile pattern points, extend the line so that it reaches beyond the graph. The line you draw is a model that models the growth of the tile patterns. Models are often imperfect, but they are useful in describing situations and making predictions. What assumptions does the linear model make about this tile pattern? It assumes there are decimal figure numbers and tiles. So it assumes there are decimal figure numbers and tiles. So if you do want to connect the line, connect the dots, it's going to be a model of how far and how high that goes. But realistically, for figure numbers, connecting the dots is not always necessary. Does the model in the previous problem appear to be a function? Yes. If I draw a vertical line through this function, I will get that it only goes through one dot. So let's explain why. Is it a function? Yes. Every input has exactly one output. Then it says to write the equation in function notation. What this means is I should have wrote, I'm typically writing y equals mx plus b. So this time we're just going to write it as f of x equals mx plus b. So let's flip over. What's the slope? What's the growth? The growth, it's going up by 5 each time. You can also see it in the table. It's growing up by 5. So that's the slope. M equals 5. I'll write it right here. What's the starting value? Our b. Our starting value is 2. So how would I write this in function notation? Instead of writing it as y equals 5x plus 2, I'm going to write it as, let's flip our paper, f of x equals 5x plus 2. So, excuse me, that was just a little bit of a transition for going into second period right now, but I'm recording this right as we transition to our next class. But 2-1-3-13 says the 3 graphs model a different tile pattern. For these ones, we want to write the equations, so we want to practice writing equations for these. So for the first one, letter A, let's write the equation of letter A. And we're answering the questions that are on the back here. It kind of cut off. I'm sorry about that. It cut off because it printed on the wrong page. But let's just go ahead and write our answers here. What's our growth? Our slope. Growth is rise over run. So it looks like it's going up by 2 each time. 2 tiles every time. If you see, it goes up by 2 over 1. So the rise is 2, the run is 1. What is our y-intercept? The y-intercept is 3. So we can go ahead and say the equation for this one is y equals 2x plus 3. Okay, let's try the next one. The next one is pretty confusing, but we look at these numbers and we can see that there is enough information for us to come up with an equation. So what's the rise over run for this one, which is the slope? It looks like it's going up 12 and over 1. So what's 12 divided by 1? It's going up 12 over 1, which is 12. What's the y-intercept? Our b? It's 9. Our starting value is 9. So what's the equation? Y equals 12x plus 9. Okay, and the next one. The next one is, what's our slope? Rise over run. It looks like it's going up 1 and over 1. What's 1 divided by 1? Yes, 1 divided by 1 is 1, so our slope is 1. And what's our y-intercept? Our y-intercept is right there at 3. So how do you write this one? This one's often mistaken and written down really weirdly. But the slope is 1x plus 3. Strangely enough, have you ever said 1x plus 3? Is your name 1 Aussie or 1? What's your name? Is your name 1 Heath? Is your name 1 Robert? Is your name 1 Alondra? Is your name 1 Xochitl? Or is it just Aussie? Is it just x? So instead of writing 1x, you could just say y equals x. My name is Aussie, not 1 Aussie. So therefore, you don't need to write the 1. That would be your answer. This would be your answer. And this would be your answer. So go ahead. I want you to use these ideas that we talked about with rise over run, which is also known as change in y over change in x. And I want you to answer the remaining pages in lesson 2.1.2. Go ahead and do that now. Help each other out.